In this lesson, we're going to finish up electrical install, and we're going to do it by applying the electrical labels on all the equipment. And this turns out to be really important. Putting on the labels is probably the number one, if not number two, most common reason for installations to fail, because either you don't put on enough labels or not in the right place or not the right label, and so on. It's a little complex, but let's jump into it, okay? I do want to mention that as a resource for this lesson, you've got this guide, solar labeling guide that we've made up for this particular installation. It identifies each of the types of labels that we're going to be applying and also shows you exactly where in the actual overall installation those labels are going. So you may want to print that resource out just as a guidance for doing the lesson, but also as a permanent record to keep an idea of which types of labels go where. So we're going to begin up at the array, and we're starting out at the array junction box. So this is our array junction box. If you have any box at all, it would need this label, and it's a warning photovoltaic power source label. And the way we're going to put on the label is touch it, and it's going to apply to the surface of that junction box. Now, it's real important. I want to highlight that we have information block here. I'm going to bring it up. The warning photovoltaic power source label, the one that we've put in here, is the most frequently applied label. It's used all over the place. It's required on every conduit body and junction box like this, and every conduit body like the LLs and the LRs. It has to be within 1 foot of the bend of a conduit, turn or bend, within 1 foot of a penetration of the roof or ceiling or wall, and every 10 feet along conduit. So it's used in a lot of places. So we're going to continue. We're moving on to the conduit from the array junction box, and there again we begin by applying these warning photovoltaic power source labels. I'll click again. There's another one that's applied because that's about less than 10 feet away, and there's a third one that's applied. Remember, the run of conduit was way more than 10 feet, and we're going to put on 3 labels just to be sure we cover ourselves. Then we have a conduit body. Remember, the conduit body up at the roof? And that also needs a label. So we're going to apply a conduit label to the front cover or to the top cover of this conduit body. Then under the roof, we also had conduit bodies as well, remember? And so we're going to apply the warning label to that conduit body as well. And we have conduit exiting the overhanging eave, so we're going to apply that same label as soon as we can right there. Now, going along our conduit run, within 1 foot of a conduit bend, we also want to apply that label again. And then since this conduit run down the wall is quite long, we have to put it every 10 feet, remember? So we apply another label. And then there's a whole series of them here. The conduits coming down, we have a conduit body as well, and pieces of conduit coming down to the inverter. So we're going to touch on them. We apply it to a conduit body. We apply them to the section of conduit and to the beginning section of conduit and within 1 foot of the bend of that conduit. So that's the label that's used an awful lot. And the critical thing to understand about that label is that's on the DC run. You're going to have AC conduit that will not require that label. That's only required on the solar DC conduit runs. Now let's start looking at some other labels. On the inverter is where the DC disconnect is for the system. This is the DC disconnect of the DC conductors coming in to the DC to AC inverter. Let's click on the More Info note here and realize that the DC disconnect switch needs to be identified and its typical operating values need to be listed. So we have to say that this is where the DC disconnect is. There's also perhaps going to be an AC disconnect. See, that's different. So we're identifying the DC disconnect here. And there's also a requirement for a label of the maximum voltage of the system and the maximum circuit current of the system. And that label needs to be filled in with the actual information for this particular job. So that label is perhaps different for every single install. It has to be appropriate for that inverter and that installation. The label goes through, the information goes through and explains that in our case, for our particular system, we consult the manufacturer's literature, and their maximum DC operating voltage is 500. That's on the DC side. And the maximum DC current, in this case, we have 2 strings of optimizers. The manufacturer says that their maximum current is 15. So we have 2 of them. So the maximum DC current we could have is 30. So that's what goes on this label. So we're going to apply the label that says that this is the DC disconnect, and we're going to apply the label that gives the DC values. Now, because we're using an optimizer system in this case, the rapid shutdown switch, the compliance for rapid shutdown, occurs here because when we turn the DC switch, it turns off the power to the optimizers and they perform the rapid shutdown of any dangerous voltage at the array. So we have a label saying rapid shutdown switch is here. It might be a separate switch in some systems. That's why it has its own label. But in this case, that capability is built into this switching system. So I'm going to apply that label here. If we turn the DC switch off, that stops a connection to the inverter, to the optimizers. They go into their safe mode, down to safe voltage, and they comply with rapid shutdown. And then there's also the requirement for this type of rapid shutdown switch. There are 2 versions of this, and we have a whole short video that explains way more about this particular label and its alternative version. But we're going to apply this one that says turn the rapid shutdown switch to the off position to shut down PV system and reduce shock hazard in the array. That's what happens in this case. There's a red version where there's still voltage in the conduit, but here it shuts it down within the array. So that's the label to use for this system. Now we're moving on to the revenue grade meter. Now this doesn't involve switching or electronics and so on, but it does require this label. Electrical shock hazard. Terminals on the line and load side may be energized in the open position. And if you click on the information button, it brings up more information about the fact that it needs that warning because it can be energized from both the inverter side and the utility side, right? Even when the inverter has just been shut down, its output capacitors might still be bleeding off some voltage, and so there might be dangerous voltage on the inverter side as well as on the utility side. So there's a warning that it may be energized even though switches may be open. So we're going to apply that shock hazard to the revenue grade meter and go on. Now we're at the AC disconnect. So we have to say that it's the AC disconnect. So I'm using a combination label here. You might be able to get one that has just photovoltaic AC disconnect by itself, but here we have one that's combined with the required values on the AC side. We put in a DC label before. This is on the AC side. So the rated AC output current comes from the manufacturer's literature for a particular inverter. In this case, a 5,000 watt inverter has a maximum current rated at 21 amps AC, and the nominal operating voltage is the utility voltage of 240. So that's what has to be filled in for that label. So we're going to apply that one. And then it's also the type of device where if things are switched off for a moment, there may be energizing on both sides. So we need to put the shock hazard label here as well. And then finally, getting to the main service panel for the house, there's a few labels to put there. Again, there's the shock hazard label because there's a solar breaker here which is connected in some way to the inverter, and when systems are shut down, you still may have residual voltage from that inverter circuit bleeding through. So we put in that label just to make sure that people realize there might be power coming from 2 sources, not just from the utility. Then we have to put in the label that designates that it's the main system disconnect. Here is where the solar breaker is. So that's the end of the line. That's the PV system disconnect. There is an AC disconnect, but that's also where the solar breaker is for the PV system disconnect as well. So we need to label that on the cover. And then finally, we want to put on just a good safety warning that says turn off the photovoltaic AC disconnect prior to working inside this panel, because that's basically a system safety disconnect on the inverter side that would make it more safe to work inside. So those are the labels we put on the outside of the main service panel. We're not yet quite done though, because we have to go inside. Right next to our solar breaker, we need to put in this label, which is the PV solar breaker designation. We need to call out which one is solar, and also because of NEC rules, that solar breaker needs to be at the opposite end in the bus bar from the main service panel. And so we apply a label that says do not relocate this overcurrent device, telling any electrician working on the system subsequent to your installation that this is a solar breaker and its position cannot just be moved around to make room for other circuits. So we're going to place that next to the solar breaker. And you're finished. And that's the way that we will go through applying labels to your PV system.
Hey, thanks for watching the training video using Interplay's simulation-based training program. You can keep watching our solar videos by clicking on the link to your left, or stay up to date on our latest solar snacks by subscribing on your right. To learn more about how the STP provides critical team training and helps you build an onboarding program at your company, please go to interplaylearning.com.